Here is one example. Find the Fourier series of mod x. While our first discussion we have specified that mod x is going to be an even function, so no need of finding all its coefficients. In minus pi to pi, and reduce that 1 plus 1 by 3 square plus 1 by 5 square plus extra plus pi is equal to pi square by 8. So first part we should do is we want to find the Fourier series of mod x. So first of all, note that mod x is equal to mod x of minus x is equal to mod x. So mod x is an even function. Therefore, corresponding Fourier series will contain the cosine series. That is, a0 term should be there and an term should be there, but no bn terms. So bn equal to 0 for every n. Here, when we are finding a0 is equal to, using the formula 1 by pi integral 0 to pi f of x dx, and 1 by pi integral 0 to pi, how it becomes 0 to pi means exactly the interval is minus pi to pi, but this is an even function. So even functions means that integral will reduce us to 2 times from 0 to pi. So we have got a0 formula as a0 is equal to 1 by pi integral 0 to pi f of x dx. That's equal to 1 by pi integral 0 to pi mod x dx. But in between the interval 0 to pi, mod x is nothing but x itself. So we can replace that with x. Now 1 by pi into, we want to integrate x, so integration is x square by 2 in between the limits 0 to pi. So what you are getting is pi by 2. So we have got the value of a0 as pi by 2. Similarly, we are finding the value for an. Again, in an, it is exactly 1 by pi into integral minus pi to pi, but f of x is even, cos nx is even. So both are even functions. So we can write this as twice the integral from 0 to pi. So the formula will become 2 by pi integral 0 to pi f of x cos nx dx. Now again, using the formula 2 by pi integral 0 to pi, where f of x is mod x into cos nx dx. But again, in the interval 0 to pi, mod x will result x. So our integration is 2 by pi integral 0 to pi x into cos nx dx. That's equal to 2 by pi into, this is follows from the product rule of integration, that is first function into integral of cos nx between the limit 0 to pi minus integral between the limit of derivative of first, that means x, that is 1 here, and integral of second, so integral of cos nx, that is sin nx by n dx. So applying the limit, we get 2 by pi 0 minus 1 by n minus cos nx by n between the limits 0 to pi. That will result 2 by pi into n square into cos n pi, because here is coming cos nx by x. Applying pi means cos n pi will come cos n pi minus lower limit is 0, so you get cos 0, and the value is 2 by pi n square into minus 1 power n, because cos n pi is minus 1 power n minus 1 for n equal to 1, 2, 3, etc. Therefore, Fourier series for this mod x is in the interval minus pi to pi is a0 plus sigma n equal to 1 to infinity an cos nx, that's equal to pi by 2 plus sigma n equal to 1 to infinity 2 by pi n square into minus 1 power n minus 1.